Right now, as you watch this video, the Arctic is disappearing at a rate that defies human comprehension. Every single day, we lose an area of sea ice equivalent to the size of South Carolina. But what if I told you that a group of scientists believes they can reverse this catastrophe with a $100 billion plan that sounds like science fiction? The Arctic Ocean, once a fortress of permanent ice, is now a graveyard of climate predictions. Scientists call it the canary in the coal mine of global warming, but this canary isn't just sick, it's in free fall. The consequences aren't limited to polar bears or remote Inuit communities. The Arctic's death spiral is reshaping weather patterns across the entire planet, triggering extreme heat waves in Europe, devastating floods in Asia, and unprecedented droughts in North America. Here's what most people don't understand. The Arctic isn't just melting, it's accelerating its own destruction through a process so terrifying that climate scientists have nightmares about it. As white ice disappears, dark ocean water absorbs more heat, which melts more ice, which exposes more dark water. It's a feedback loop that's spinning out of control. But deep beneath the Arctic waters, a revolutionary experiment is taking place. Cambridge University researchers and a startup called Real Ice are testing technology that could literally refreeze the Arctic. The question isn't whether it's possible. The question is whether humanity can afford not to try. The numbers are staggering, and they're getting worse every year. Since 1979, the Arctic has lost sea ice at a rate of 13% per decade. To put this in perspective, we've lost an area of ice larger than Alaska, Texas, and California combined. The ice that remains is getting thinner, younger, and more vulnerable to complete collapse. The permafrost, permanently frozen ground that covers 24% of the northern hemisphere, is thawing at an unprecedented rate. This isn't just soil. It's a carbon bomb containing twice as much carbon as the entire atmosphere. When it thaws, it releases methane and carbon dioxide, greenhouse gases that are 25 and 1 times more potent than carbon dioxide, respectively. Scientists at the National Snow and Ice Data Center have documented something that should terrify every person on Earth. The Arctic is warming 4 times faster than the global average. This phenomenon, called Arctic amplification, is rewriting the rules of climate science. What was supposed to happen over centuries is happening in decades. The economic implications are equally devastating. The Arctic's ice acts as Earth's air conditioner, reflecting solar radiation back to space. Without it, global temperatures will rise faster than any climate model predicted. Insurance companies are already calculating the costs. Coastal flooding will displace hundreds of millions of people, agricultural zones will shift dramatically, and entire industries will collapse. But the most terrifying aspect isn't what we know, it's what we don't know. Climate scientists call them tipping points, and we might have already crossed several of them. In the frigid waters north of Svalbard, Norway, something unprecedented is happening. Dr. Sean Fitzgerald from Cambridge University and his team at Real Ice are conducting experiments that sound like they belong in a Hollywood blockbuster. They're using underwater pumps to spray seawater onto the surface of sea ice during the brutal Arctic winter. The concept is elegantly simple, yet revolutionary. During winter, when temperatures plummet to minus 40 degrees Celsius, the team pumps seawater from beneath the ice and sprays it on top. The water freezes almost instantly, adding precious centimeters to the ice thickness. It's like giving the Arctic a winter boost, artificially accelerating a process that nature can no longer accomplish on its own. The technology behind this operation is surprisingly straightforward. Solar-powered pumps, designed to withstand the harshest conditions on Earth, draw water from below and distribute it across the ice surface through a network of hoses. The entire system is designed to work autonomously through the long Arctic winter, when human intervention is nearly impossible. Real ice's field tests have shown remarkable results. In controlled areas, they've successfully increased ice thickness by up to 50 centimeters in a single winter season. That might not sound like much, but in the Arctic, where ice thickness determines survival through the summer melt, 50 centimeters could mean the difference between preservation and complete loss. Dr. Fitzgerald describes the work as emergency medicine for the planet. The team isn't trying to solve climate change. They're buying time for humanity to address the root causes while preventing the complete collapse of Arctic sea ice. Scaling this technology from experimental plots to the entire Arctic Ocean requires resources that dwarf most national budgets. Conservative estimates suggest that refreezing significant portions of the Arctic would cost between $50 and $100 billion annually. To put this in perspective, that's roughly equivalent to the annual GDP of countries like Morocco or Ecuador. The logistics are mind-boggling. The Arctic Ocean covers approximately 14 million square kilometers, an area larger than Antarctica. Deploying enough pumping systems to make a meaningful impact would require thousands of installations, each capable of operating independently in conditions that destroy most human-made equipment. But here's where the economics become interesting. The cost of doing nothing is exponentially higher. The economic damage from Arctic ice loss, including sea level rise, extreme weather events, and agricultural disruption, is estimated to exceed $10 trillion by the end of this century. Suddenly, $100 billion annually starts to look like a bargain. If you're finding this as fascinating as I am, and you want to stay updated on the latest developments in climate engineering, consider subscribing to our channel. We dive deep into the science and economics behind humanity's most ambitious projects. The funding challenge isn't just about money, it's about international cooperation on an unprecedented scale. The Arctic Ocean touches 8 different countries, each with their own political agendas and economic interests. Coordinating a project of this magnitude would require diplomatic agreements that make the Paris Climate Accord look simple. Private companies are already showing interest. Tech billionaires who've made fortunes disrupting traditional industries are now turning their attention to disrupting climate change itself. The technical challenges of refreezing the Arctic make landing on Mars look straightforward. Each pumping station must operate in temperatures that would instantly freeze human blood, survive storms that generate waves higher than skyscrapers, and function for months without any human maintenance. The pumps themselves are engineering marvels. They must be powerful enough to move massive volumes of water while consuming minimal energy. Remember, they're powered by solar panels during the Arctic winter when the sun barely rises above the horizon. The materials must withstand not just extreme cold, but also the corrosive effects of salt water and the crushing pressure of shifting ice. Real Ice has developed a modular system where each unit can operate independently. If one pump fails, the others continue working. The stations are designed to be deployed by icebreaker ships during the brief Arctic summer, then left to operate autonomously through the winter months. The water distribution system presents its own challenges. The hoses must remain flexible at -40 degrees, while distributing water evenly across vast areas of ice. The team has developed a network design that mimics natural river systems, with main arteries branching into smaller channels that cover maximum surface area. Perhaps most impressively, the entire system is designed to work with nature, not against it. The pumps only operate when conditions are optimal for ice formation, when temperatures are low enough and wind conditions allow for even distribution. Sophisticated sensors monitor weather conditions and adjust operations accordingly. The result is a technology that could artificially extend the Arctic winter, giving sea ice the boost it needs to survive increasingly warm summers. The window for intervention is closing rapidly. Climate scientists estimate that we have less than a decade before Arctic sea ice loss becomes irreversible. Once certain tipping points are crossed, no amount of engineering will be able to restore the ice, and the planet will enter a new climate state that hasn't existed for millions of years. The urgency is driving innovation at breakneck speed. Refreeze is conducting trials not just in the Arctic, but in laboratory freezers that simulate Arctic conditions. They're testing different pump designs, water distribution methods, and control systems. Every winter that passes without large-scale deployment is a winter lost. Other research teams are exploring complementary approaches. Some scientists are investigating ways to increase the reflectivity of existing ice by spreading reflective materials across the surface. Others are studying whether underwater barriers could slow the flow of warm water into the Arctic Ocean. The race isn't just against time, it's against physics itself. As the Arctic warms, the window for effective ice thickening becomes shorter each year. What works in today's Arctic might be useless in the Arctic of 2030. International pressure is mounting. The European Union has committed significant funding to Arctic preservation research. The United States has launched its own climate engineering initiatives. Even countries not directly affected by Arctic ice loss are recognizing that the economic consequences of inaction far outweigh the costs of intervention. But the biggest challenge isn't technical or financial, it's political. Implementing a project of this scale requires global cooperation at a level humanity has never achieved. The success or failure of Arctic refreezing technology will determine the climate future of every person on Earth. If successful, it could buy humanity the time needed to transition to renewable energy and address the root causes of climate change. If it fails, we'll face a planet where coastal cities are underwater, weather patterns are completely disrupted, and hundreds of millions of people are displaced. The implications extend far beyond climate science. Success would prove that humanity can engineer solutions to planetary-scale problems. It would demonstrate that international cooperation on unprecedented scales is possible when survival is at stake. It would mark the beginning of an era where humans actively manage Earth's climate systems. Critics argue that such massive intervention in natural systems is dangerous and unpredictable. They worry about unintended consequences and the moral hazard of treating symptoms rather than causes. These are valid concerns that researchers are taking seriously as they design and test their systems. But supporters argue that we're already conducting a massive, uncontrolled experiment on Earth's climate through greenhouse gas emissions. Arctic refreezing, they contend, is simply a controlled intervention designed to counteract the damage we've already done. The next 5 years will be crucial. Refreeze and other research teams are scaling up their operations, moving from small test plots to larger demonstration areas. The data from these trials will determine whether the technology can be deployed at the scale needed to make a real difference. The stakes couldn't be higher. The Arctic Ocean that our grandparents knew may already be gone forever. But the Arctic Ocean that our grandchildren inherit still hangs in the balance. Thank you for watching this deep dive into one of humanity's most ambitious climate engineering projects. The future of Arctic ice and our planet's climate stability depends on innovations like these and the global cooperation needed to implement them. If you found this exploration of cutting-edge climate science as compelling as I did, please subscribe to our channel and hit the like button. We're committed to bringing you the latest developments in humanity's race to address climate change, and your support helps us continue this important work. What do you think about the prospect of artificially refreezing the Arctic? Share your thoughts in the comments below.